day 623 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2975, maximum square area by removing fences from a field. The difficulty level is medium, but don't worry because you already know that we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a large n minus 1 by n minus 1 rectangular field with corners at 1, 1, and mn containing some horizontal and vertical fences given in arrays h fences and v fences respectively. Horizontal fences are from the coordinates h fences of I and 1 to h fences of I and n, and vertical fences are from the coordinates 1 to v fences of I to m and v fences of I. Return the maximum area of a square field that can be formed by removing some fences, possibly none, or -1 if it is impossible to make a square field. Since the answer may be very large, return it modulo 10 to the 9th power plus 7. Note, the field is surrounded by two horizontal fences from the coordinates 1, 1 to 1n and m1 to mn, and two vertical fences from coordinates 1, 1 to m1 and 1n to mn. These fences cannot be removed. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input, m equals 4, n equals 3. H fences equals an array of integers 2 and 3. V fences equals an array of integers 2. So let's break this down one step further. M fences, that means we are going to have a 4 by 3 grid, right? So it's going to be 4, 1, 2, 3, 4 vertical lines and it's going to be 4 horizontal lines and 3 vertical lines. 1, 2, 3. Now remember these edges, these two vertical lines or these two horizontal lines cannot be removed, and these two vertical lines cannot be removed. So we're only worried about this horizontal line, and this horizontal line. Then in H fences, we're allowed to move either this horizontal line or this horizontal line, and V fences is 2, so we're allowed to move this horizontal line. But we don't have to remove all of them, right? It says by removing some fences. So we can remove one of these or some of these. We don't have to remove all of them, or we can remove possibly none if we want to. Boom. So in this case, the output is 4. Explanation says removing the horizontal line at fence 2 and the vertical line at 2 will give a square field of 4. So if we remove this vertical line right here at 2, right, boom, then we remove this horizontal line right here at 2, boom, we'll be left with this, and this is a square, right, boom, that's what we want. But we're not done because we need to return the area of this square. So this square has a length or a height of 1 to 3, so it has a height of 2. Then it has a width of 1 to 3, so it has a width of 2. The area is going to be the height times the width, right? So if it's 2 times 2, that's going to get us 4, and that's why our output is 4. Now, just in case that didn't make sense, y'all, let's take a look at example 2, where in case they try to throw a trick question our way and we cannot form a square at all. So in example 2, we have our input m equals 6 and n equals 7. H fences equals 2, V fences equals 4. So as you can see, we only have one fence here and one fence here, right? We're not going to be able to remove these fences on the border because then we wouldn't have a grid at all. Boom, so we can only remove these. But as you can see, even if we remove this one, we won't have a square. And even if we remove this one, we won't have a square. So there's not really anything we can do there's not really any fences we can remove from this grid to create a perfect square, right? Because we're already starting with a length or a height of 6 and a width of 7. So that's already off by 1. So we can't just delete both of these and then the whole grid is a square. And then there are no other squares that we can create within this grid. So the output is -1. It says it can be proved that there is no way to create a square field by removing fences, y'all. So I hope that makes sense to y'all now that we understand the question. And let's get into the fun part, the actual solution. Solution is not that difficult. Now, the first thing we want to do is we want to handle this modulo this modulo 10th to the 9th power plus 7. So we're just going to say let mod equal 1 underscore 000 underscore 000 underscore 007. Boom, just like that. Now we're going to create a helper function that computes all possible distances between pairs of fences, including the grid boundaries. So we're going to declare, come right here, create a func, call it diffs, open up the parentheses, underscore fences, colon, it's going to be an array of integers. Come outside of that, we're going to say comma, underscore bound, colon, that's going to be an integer. Boom. Then we're going to come outside of that, and it's going to return a set of integers. Boom, just like that. And we're going to open up the brackets. Boom. Then we're going to add the two grid boundaries, one and bound, to the fence list and sort all fence positions. So we're going to say let f equal, open up the parentheses, fences plus square bracket 1 comma bound, come outside of that, and we're going to say dot sorted, open up the parentheses. Then we're going to set to store all unique distances between fence pairs. So we're going to declare variable called s, and we're going to set that equal to a set of integers again. So set less than and greater than, put the parentheses to initialize it, and then we're going to say let c equal f dot count. Boom. Now we're going to compute all possible differences between fence positions by coming underneath this, or excuse me, oh yeah, that's right. We're going to come underneath this, and we're going to say for I in 0 dot dot less than c. We're going to open up the brackets. We're going to say for j and I plus 1, open up the brackets. Oh, excuse me, 1, sorry, this should be 1 dot dot less than c. Then we're going to open up the brackets, and we're going to say s dot insert, open up the parentheses, f square bracket j, come outside of that, minus f square bracket I. Boom. Then we're going to come underneath this for loop, still in this helper function that we just created, and we're going to return s, just like that. Now we need to create a constant outside of this helper function that's for all possible horizontal gaps, or the height. So we're going to say let hs equal diffs, open up the parentheses, h fences, comma, m. Then we need all possible vertical gaps, or the widths. So we're going to come underneath this, and we're going to say let vs equal diffs, open up the parentheses, v fences, comma, n. Now we need to track the largest possible square side length by coming underneath this and declare, we need to declare a variable called best equals -1. Boom. Now we need to find the largest distance that exists in both horizontal and vertical gap sets by coming underneath this, and we're going to say for d in hs where vs dot contains, open up the parentheses d. We're going to come outside of that, open up the brackets, and we're going to say best equals max, open up the parentheses, best, comma, d. Boom. But we're not done yet, y'all. If no common distance exists, then no square can be formed. So we need to come right here, and we need to say if best is less than 0, then we're going to open up the brackets, and we're going to return -1. Boom. Then we're going to return the square area modulo the best, or we're going to return the square area mod the best required value. So we'll come underneath this, and we'll just say return int and open up the square bracket. Open up the parentheses, open up some more parentheses. We're going to say int 64. Open up some more parentheses, say best, come outside those parentheses, we're going to say times int 64, open up parentheses best. Then we're going to come outside of these two parentheses, still inside the other parentheses, and we're going to say mod int 64, open up the parentheses mod. Boom, y'all. So that should be all she wrote. Let's give it a run before we submit it. Let's see. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 540 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today. Or before we go, though, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.